Hello everyone, welcome to MATHFREAKS. So let's start today's session. So today let us first of all revise Newton's sum that we learned in the last lecture, and we are going to do a bit of modification in that Newton's sum. So today's topic is Newton's sum again, and today we are also going to discuss some really good questions on Newton's sum. Now again, that same concept, that we have a general equation, say ax square plus bx plus c is equals to 0. This is an equation, right? General equation. Now this equation has alpha and beta. We are going to revise Newton's sum a bit. Okay, so again we can write it as this. We can write as a alpha square plus b alpha plus c is equals to, or let me write it like this. Is it wrong if I write something like this? No, right? Because alpha raised to the power 0 will be 1 and c multiplied by 1 will be c. Similarly, we can write it as beta square plus b beta plus c beta raised to the power 0 is equals to 0. Okay, 0. Correct. Now what we did in the last lecture, we multiplied the above equation with alpha raised to the power n minus 2 and the bottom equation with beta raised to the power n minus 2, and then we added both of them. Now is this step correct? You may have a question, but yes, this step is correct. Why? Because if you say a plus b plus c, their sum is 0. So if we multiplied a plus b plus c with any number or anything, the answer will still be 0, right? If I multiplied with any number, say k, this will still be 0, right? So we can write this step now, and we added this, and finally we got if you do all of this, we will get a alpha raised to the power n plus beta raised to the power n plus b alpha raised to the power n minus 1 plus beta raised to the power n minus 1 plus c alpha raised to the power n minus 2 plus beta raised to the power n minus 2. 0, right? And we defined an, right? An is we defined an as alpha raised to the power n plus beta raised to the power n. Okay, an we have defined as nth, the sum of the nth power of the roots. Defined an like this. So finally we can write this whole equation as a multiplied by an plus b multiplied by a n minus 1. We can replace n, right? We can replace n with any number. So now a multiplied by an plus b multiplied by an minus 1 plus c multiplied by an minus 2 is equals to 0. Very simple, right? So we can, if we know the roots of an equation, we can write the Newton's sum directly like this, right? Now as I'm telling you, with the help of a quadratic equation, it is not like that you like the Newton's sum can only be applied on a quadratic equation. It can be applied on any degree equation, right? It can be 6 or n degree equation. So this is true for all equations. Now this was the content that we learned in the previous lecture. Now what modifications we will do to it? Have a look at this step. We will modify or some changes in this step. Now what changes? As I told you, if you like a few minutes ago, that if we multiply anything to like say I gave you the example a plus b plus c is equals to 0. So if I multiply anything with this one, the answer will always be 0, right? So generalizing this idea, we have previously multiplied it with alpha raised to the power n minus 1 and beta raised to the power n minus 2. Now can we also multiply it the same with, say, multiplied by p alpha raised to the power n minus 2, and p can be any say natural number or anything, right? P is a constant. It's better to say p is a constant. P can be anything. Constant, right? P is a constant. And similarly, now in the second, that is beta raised to the power n minus 2, you can multiply here again p. That would make no difference, but also let's say we can write it as q by generalizing it, minus 2, where q is also a constant, and say p and q can be equal. P and q can be equal, and p and q can also be different, right? Now if we add them, I hope you understand that we can multiply p and q, right? Because this will make no difference. Now if we add this to equation, let's see what we are going to get. Everything will be same, but except we will get an additional p and q, right? So this would be a multiplied by p alpha n plus q beta raised to the power n plus b multiplied by p alpha n minus 1 plus q beta n minus 1 plus c p alpha n minus 2 plus q beta n minus 2. And if we again define, say, an, okay, an, like also you can a dash and whatever, so I'm going to define it as an again. So an for us now is p multiplied by alpha raised to the power n plus q beta power n. This is our new an. We have redefined an as this thing. Correct? We can do so, right? Now finally we can write our equation as a multiplied by an. Again the same, just we have like we have a p and q extra. An plus this is our new modified, if you want to say that, modified number, Newton sum. Okay, so this is our Newton sum. Now let us practice a few questions. First of all, the question is something like this: px is a polynomial defined as x cube plus 3x square plus 4x minus 8. Okay, and it has roots, say, alpha, beta and gamma. Then you are asked to find alpha square plus beta square plus gamma square and alpha raised to the power 4 plus beta raised to the power 4 plus gamma raised to the power 4. Now as I told you that Newton's sum is not limited to a quadratic equation, here you can see that we have given you a question with of cubic equation, and here you will apply Newton's sum. Another thing that you can understand from this question is that how helpful Newton's sum is. Like this you can find it with the Vieta's relation that I taught you in the last lecture, but here you will struggle a lot if you have not understood the Newton's sum properly. Okay, so try this. Done. I'm like you can pause the video and just try it by your own. Now let's start with the solution. First of all, as I told you that any equation can be written like a in that form, so simply here we can write it as 1 multiplied by 1 multiplied by an plus 3 multiplied by a n minus 1 plus 4 multiplied by a n minus 2 minus 8 multiplied by a n minus 3 is equals to 0. Correct? How we can write this? Because see the coefficients, like we defined it as a multiplied by a n plus b multiplied by a n minus 1. What were a and b and c? They were the coefficients of their respective variables, right? So say since here the coefficient of x cube is 1, x square is 3, x is 4, and x raised to the power 0 is 8. So we have written here 1, 3, 4 and 8. Okay, I hope that you understand now. Now we are asked to now this can be defined as a4. Okay, a4. Now another question may come to your mind that, sir, you defined an as p multiplied by alpha raised to the power n plus q multiplied by beta raised to the power n, but here you are simply telling that an is equals to alpha n plus beta n plus gamma n. Now why? If you remember that I told you that p and q can be equal, and here the value of p and q is 1 and they have equal values, which is 1. So I am still correct, right? Now let's try to solve this. First of all, what we will do, let's place a n as 3. So a3 plus 3a2 plus 4a1 minus 8a0, like a0 is equals to 0. Correct? Now what is a1? A1 is alpha plus beta plus gamma, and using Vieta's relation we can tell that this is minus minus b upon a, right? So this will be minus 3. Correct? So a3 plus 3a2 we can write it as minus 4a1 plus 8a0, and since a1 is minus 3, this will be 12 plus, and a0 is alpha raised to the power 0 plus beta raised to the power 0 plus gamma raised to the power 0, which is 3, right? So this would be 24, right? And they would add up to 36. So from here we have got that a3 plus 3a2 is what? 36. Now you can easily, now see, we were asked to find a2 and a4. Now a2 you can easily find out using Vieta's relation, and if you do so, you will get a2 as I think, wait a bit, this would be, okay, this would be 1, right? a2 will be 1. Yes, a2 will be 1. How did I find this? A2 is alpha square plus beta square plus gamma square. This can be written as alpha plus beta plus gamma whole squared minus 2 alpha beta plus beta gamma plus gamma alpha, right? So this is 4 and this is 3, so 3 square minus 8, that is 1. So a2 we have got as 1, so a3 would be 33, right? And if you got the value of a3, then a4 is very simple, just put a n as 4, and then you will get an equation that is a4 plus 3 a3 plus 4 a2 minus 8 a1, and you have all the values of a1, a2 and a3, and hence you can find a4. I hope that you understand. Okay, so to reduce the confusions that you have, that like if you have that Newton sum is only applicable for quadratic equations, let me write you the the general for a general polynomial, right? So how it would look like? So we all know that general equation something looks like this. Okay, wait a bit. an multiplied by x to the power n plus an minus 1 x raised to the power n minus 1 plus an minus 2, and then x raised to the power n minus 2, and so on and so forth. Now we will define here an as, say k1, like k multiplied by alpha raised to the power n, alpha 1 raised to the power n plus, say, m. Okay, let me define am, because n we have already used. So alpha 1 raised to the power m plus alpha 2 raised to the power m plus alpha 3 raised to the power m, and so on up to alpha n raised to the power m. Similarly, this would be plus, say, k1 if I define this, then with k2 beta 1 m, sorry, this is okay, sorry, okay, this will be the am, like, right? So if this is the am, now how can we write Newton's sum for this general equation? This would be an, very simple, this would be an multiplied by am plus an minus 1 multiplied by am minus 1 plus an minus 2 multiplied by am minus 2, and so on, like this. So this is for general equation, no? General equation. Okay, I hope that you now have no confusion that Newton's sum is only for quadratic equation. You can apply it on any equation. Now, yes, this question, okay, this one is I guess from AME, and very simple question. Have a look at the question. Okay. Done. Now let's solve it. Now the equation that has been given to us is x cube minus 5x square plus 8x minus 13, and the question is like, let sk denote the sum of the kth power of the roots of the polynomial this. So from here we can directly write it as say sk minus 5s minus, okay, so this we can write as sk minus 8s k minus 1 minus 5 plus 8, okay, minus 5 sk minus 1 plus 8 sk minus 2 and plus 13, right? Minus 13, okay, minus 13 sk minus 3. Now what has been asked? To find a plus b plus c, like this, and given s naught and all this. Okay, now from here this is equals to 0. Can we write sk is equals to 5 sk minus 1 minus 8 sk minus 2 plus 13 sk minus 3, right? So correct. Now do you see kind of a similar thing or similar situation right here also? Now how to get sk like this, all like a multiplied by sk minus 1 and sk minus 2. If I replace k with k plus 1, will I get that? Yes. So I can replace k with k plus 1, then this will something look like this. This will something look like sk plus 1 is equals to 5 sk k plus 1 minus 1 minus 8 sk plus 1 minus 2 plus 13 sk plus 1 minus 3. So this gives us sk plus 1 is equals to 5 k 5, right? 5 sk. Five sk minus 8 sk minus 1 plus 13 sk minus 2. And if you compare these two equations, you will find your answer, this one and this one. So from by like comparing the coefficient, it gives us that a is equals to 5, b is equals to minus 8, okay, minus 8, and c is equals to 13. So this gives us, if we add a plus b plus c, this gives us 10 as the answer, right? So I hope that you understood. Very simple with Newton's sum. Okay, very simple. Now if you try to do it with Vieta's relation, that would take you a very, very long time. I hope that this is now clear. Okay. Okay, now this is the question. Very simple but very calculative one. This question is a PYQ of AIMEI, suppose, and the year is most probably 2019. So try it out, pause the video and try to solve this. Done. Now let's begin with our solution. Now first of all, the question is, consider the polynomial px, and the polynomial is given, and qx, this one, given that z1 z2 z3 and z4 are the roots of qx, that is this one. Find p of z1 plus p of z2 and this and that. Okay, now it is basically asking a very simple question, but in a confusing way. How? Let me tell you this. For so let's say the roots are not this one, because this will be tough to write. Say the roots are, say, qx. Let me just zoom in. So qx has roots a, b, and a, b, c and d. Okay, these are the roots of qx. Now they have asked us to find p of a plus p of b plus p of c and plus p of d. Now if you have a very close look of the polynomial, this px, and if you replace x, like the value of the polynomial, with a, b, c and d, you will find that this is nothing but, basically they are asking us to find a6 plus b6 plus c6 plus d6 minus a5 minus plus b5 plus c5 plus d5 minus, and so on. So basically, like, we defined a n, right? So we can directly write that they are asking us to find a6 minus a5 minus a of 5 minus a4 minus a3 minus a2 minus a1, right? Sorry, no 4 except this. So a6 minus a5 minus a3 minus a2 minus a1. So this is now our question, very simplified. So if there is an equation which is x to the power 4 minus x cube minus x square minus 1, this is our equation, and we have 4 root, that is a, b, c and d, and we are asked to find this. So very simple. Now let's form the Newton's the Newton sum version of this equation. Now very important thing that I want to draw your attention on, a very important mistake that you may do. First of all, let us write this in the form of general biquadratic equation. That would be ax to the power 4 minus bx cube minus cx square minus, say, plus dx plus e. Okay, now if I want to form the Newton's sum version of this biquadratic equation, that would be a multiplied by an plus b multiplied by an minus 1 plus c multiplied by an minus 2 plus d multiplied by an minus 3 plus e multiplied by an minus 4. So this is what the Newton's sum version of this general biquadratic equation would look like. Now we want to transform this biquadratic equation into Newton's sum version, right? So why did I write all of this? Because if you looked at this biquadratic equation very carefully, you will find that this term is absent here. Okay, this term is not here, so we can say that here d is equals to 0 in this equation, correct? In this biquadratic equation the value of d is 0, so here also this term would not be there in this Newton's sum like the Newton's sum version of this biquadratic equation. Rest a is 1, b is minus 1, c is minus 1 and e is also minus 1. That is very clear. We just compared the coefficient and here d was 0, hence this term will not be there in the Newton's sum version of this biquadratic equation. So if I want to write the Newton's sum version for this biquadratic equation, that would be an minus an minus 1 minus an minus 2 minus an minus 4, correct? Okay, correct. Now this is our Newton's sum version for this biquadratic equation. Now it's very simple question. You have now this is equals to 0, okay? Don't forget to write that. This is equals to 0. Now how to solve this? As I told you, the question is very simple but it's very calculative one. So first thing that now here also you will need the Vieta's relation. How? Let me tell you. First of all, let's replace n with say 3. So a of 3. Now what is an? If you have forgot any time writing here, an is equals to a raised to the power n plus b raised to the power n plus c raised to the power n plus d raised to the power n. Okay, so a3 minus a2 minus a1 minus a of minus 1 is equals to 0. You know a2 how? Using Vieta. You know a1 how? Using Vieta. Now you have to find a of minus 1, which is very simple. How? Let's see how to find a of minus 1. A of minus 1, if you know what is an, which is nothing but minus 1 plus b to the power minus 1 plus c to the power minus 1 plus d to the power minus 1, and if you just add them, this would be abcd, then this would be bcd plus acd plus abd plus abc. This is what you will get if you add them. So this is equals to a of minus n. Now you know this value. You know this value how? Using Vieta. And you also know this. What is this? What is this numerator? This numerator is the sum of the roots taken 3 at a time, which I taught you how to find, and this is the product of the roots. So these two things are very simple to find using Vieta's relation, so you can do that. So you have the value of a of minus n. Now if you have the value of a of minus n, you also know this one. You also know, wait a bit, you also know a of 1, which is just the sum of the roots. You also know this value, and hence you will get this a3, correct? Now you have the value of a3. Now again, if I take now n as say 4, so a of, if I take n as 4, what will be a4 minus a3 minus wait a bit, If I take 4, this would be a4 minus a3 minus a2 minus a0. Or sorry, if I take ns6, now this is just trial and error method. If I take ns6, so this would be a6 minus a6 minus a5 minus a4 minus a2, a6 minus a5 minus a4 minus a2 is equals to 0, or we can write a6 minus a5 minus a2 is equals to a4, and we were asked to find this. So from here we can write it as a6, a5 and a2, so a of 4 minus a3 minus a1. You know this value, you can find this value, hence you can ultimately find this value. I hope you understand. I just replaced 6 like n with 6, and this relation came that a6 minus a5 minus a2 is equals to a4. Then I replaced it in the original question, and hence we got this. We have reduced our question to this part. So now we know a3, we know a1, and we have to just find a4, and hence your answer will be in front of you. So these were all the applications of Newton's sum. I hope that you have understood Newton's sum very very interestingly. Now if any problem comes in PRMO regarding Newton's sum, I am hoping that you will be able to solve this very simple topic, that is Newton's sum. Now let us move on to the next topic. Okay, in the last lecture we discussed about nature of roots, like not in the last exactly, but in some previous lectures we talked about the nature of the roots. Now let us revisit that a bit. So nature of roots is our next roots. Okay, now nature of roots, we talked about three natures. If alpha and beta, say we have a generally quadratic equation, that is ax square plus bx plus c is equals to 0, which have two roots, that is alpha and beta. So if alpha and beta they are real, then we are told that discriminant has to be greater than 0. Now why? I'm going just wait a bit. For b, alpha and beta, if they are imaginary, then discriminant has to be less than 0. And if alpha and beta they are equal, now if they are equal, then discriminant has to be equals to 0. And now in many books I have seen that it's written that if alpha and beta are real, then discriminant is greater than or equals to 0, which is it's the merging of these two cases, because if alpha and beta are real, they can also be equal. So in that case this you can use, but if said that alpha and beta are real and distinct, then this one only. Okay, so I hope that you understand what I meant by that. So you will use this condition is for alpha and beta, they belong to real and alpha is not equals to beta, and and say d, if alpha and beta belongs to real number, some books say that then discriminant is greater than or equals to 0. So I told you that this is the merging of these two cases, that alpha and beta can be real and at the same time they can be equals to, like they can be equal to each other as well. So for that thing, this case is here. Okay, now let's have a look at the graphs of this nature of roots. But before that I want to talk about a bit about parabola, like not necessary, but for the interest of mathematics. Parabola, not much, very little. Now parabola, one basic thing is that ax square plus bx plus C. All of you know that the graph of this quadratic equation or equation is a parabola. Now there are two types of parabola, that is upward parabola and like down facing parabola. So when will be this one, when will be this one? So this this parabola is for when a is greater than 0, at that time this parabola, and when a is less than 0, then this parabola, this is 0. Okay, this parabola. So that's only what you need to know about before understanding the graph of the nature of the roots. So let's talk about the graph. That is the first graph, which will be if alpha and beta are real, then discriminant has to be greater than 0. So the graph is very simple. So the graph can be like this. Okay, so you see that alpha and beta, say this is alpha. If I write if I write like this, so this will be alpha and this will be beta. So you see that if this is x-axis, this is y-axis, so alpha and beta are roots, and they are real because they lie on the number line, right? So that's what we mean by real. And now again another graph of the same same nature can be formed, like downward parabola, something like this. This graph is also possible when a is less than 0 and here a is greater than 0, right? So if you want to write only this graph, so you write the conditions: a greater than 0, this and this. These are the four conditions. Okay, now let's move. I hope that you understood this graph. Now let us move on to the second graph, that is of roots being imaginary. So alpha and beta, they are imaginary, and discriminant is less than 0, and again we are drawing for a greater than 0. So this would be, this graph is something like this. See, like the roots don't cut the x-axis, so they are imaginary. Now again you may have questions that what is an imaginary number. For now you can understand this like something that cannot be represented on the number line. The most basic definition of imaginary numbers can be like numbers that cannot be represented on the number line. These are imaginary. The name only says, like in the imagination such type of numbers exist, like root of -1, which is popularly known as iota. This is imaginary number. So I hope that this one is also clear. And the last graph that we will talk about is the roots being equal, right? If alpha is equals to beta, then discriminant is equals to 0. We are drawing the graph for a greater than 0. So this graph is something like this. Again, no, the major confusion here is that most of the students have that, sir, here only the graph is cutting at one position, so the equation has one root. That is not true, because we have already defined a condition that the roots are equal. So you say if the points are same, then in how many, in like only one, the graph will cut only one point, right, at one point, if both the roots are equal. So it's clear, I guess. So these were the three graphs regarding the nature of roots. Now one more important thing that I want to talk about is when given that roots are integer. Okay, roots are integer. Listen very carefully, because we are going to solve some questions based on this. When roots are integer, it has been said that roots are integer in the question, then you will then we have to equate discriminant to a perfect square, then only the root will be an integer, correct? Discriminant, now I hope that you know that is b square minus 4ac is a perfect square, right? Perfect square. And also, okay, that thing we will discuss while solving questions. So I hope that this is clear. When roots are given to be integer, then discriminant has to be a perfect square, correct? Now let's move on to questions. So the first question is something like this. If this equation x square minus 63 x plus k is equals to 0, this quadratic equation has roots which are prime, both the roots are prime, then find the value of k. For how many values of k the roots will be prime? This is the question. If roots are prime, find values of k. Pause the video and try to solve this. Done. Let's now begin. So this is a very simple question again. So say alpha and beta are the roots of this equation. So using Vieta's relation, we can say that alpha plus beta is equals to 63 and alpha beta is equals to k. Now here comes a very beautiful observation. Alpha and beta is equals to 63, right? Which is an odd number. Now I am telling you that one of the root have to be 2. Now why? This is the question. Why? This is observation, because take any 2 prime in the world except 2, add them, you will get an even number. Say 17 plus 15, even number. 13 plus 19, even number, divisible by 2. So like this is observation, so I hope that you understood that if we add 2 prime numbers except 2, then the answer is always an even number. So that's why, and since here it is given that the sum of 2 prime numbers is 63, that is an odd, so one of the prime has to be 2. Did you understand this? This is a very beautiful observation. So if one of the roots have to be 2, say alpha is 2, so beta would be automatically 61, and alpha we have already got 2. So from here we will get k as 122 as the answer. Correct? I hope that you understood this question. Very simple. Just the observation was made that the sum of 2 prime numbers except 2 will always give an even number. I hope that this question is clear to all of you. Now let us move on to another interesting question based on the concept of integer roots. So the question is that for how many numbers a does the equation, like quadratic equation, x square plus ax plus 6a is equals to 0 has only integer roots? Question from integer root has come in front of you. Use the concept that I taught you, that is the discriminant is a perfect square. Pause the video and try to solve this. Done. Now let us move on with my solution. Say alpha plus beta using Vieta's relation is minus a. correct? Now alpha and beta are integer. Listen very carefully. Alpha and beta both have been given that they are integers, so their sum will also be an integer. Sum of two integers is always an integer, so definitely a must be an integer. A must be an integer. Okay, must be an integer. Now what's next? Now use the concept that I taught you, that the discriminant must be a perfect square. So here the discriminant is a square minus 24a. A square minus 24a has to be some perfect square for us. Let's say perfect square of an integer. Obviously again a is an integer, a square will also be an integer, and 24 multiplied by a, which will also be an integer. So this is the perfect square of an integer. This is also a very important observation. So say the integer be k, so a square minus 24a is a perfect square of the integer k. K is also an integer. These are very crucial observations that you have to make. Now what? Now let's make a perfect square here. So this would be a minus 12, right, is equals to k square plus 144. That's, that's what's coming in my mind, because see how minus 24, so this can be 2 multiplied by 12 multiplied by a, so a is already here, so we have to just bring 12. So for that, since this is an equation, we have to add 144 right here, that is 12 square. So I hope that you have understood this step as well. Now again make another observation, that see k is an integer, 144 is an integer, sum of two integers is an integer, and here also it is an integer, and it's the perfect square. So k square plus 144 is a perfect square of another integer. Are you understanding? I hope that you are not confused. Again see, alpha and beta are integers, so their sum is also an integer, and according to the concept that I taught you, that if the roots are integer, then the discriminant has to be a perfect square. So here a square minus 24a has to be a perfect square of some real number. But now have a look, a is integer, so a square minus 24a is also an integer, so a square, so the discriminant is a perfect square of an integer, and here the integer is k. Now we made a perfect square in the left hand side, that is a minus 12 whole square, and in the right hand side we have k square plus 144. Since k is an integer, so we can say that k square plus 144 is a perfect square of another integer, say p square. Now what? Now very simple. This would be, if you take it here, so k square minus p square, that would be k minus p, and k plus p is equals to 144. Now what? How to solve this? Now you write the factors of 144. There will be 15 factors, and you have to pair it. So you can write this is equal. Now let me write the factors of 144. Not I'm not going to write all of them. So 1 comma plus minus 144, then we have plus minus 2 comma plus minus 72, and so on and so forth. Now there will be, I guess, 9 pairs like this. So how to solve this? To solve this, you have to use a trick or common sense. If you have an equation, say a minus b, a plus b is equals to, say, a prime number 3. So what you do is you make any one of them, say a minus b as 3 and a plus b as 1, as 1 is only there. Then what you do, you add them so that you get rid of the b, and hence you find the value of a. For us here, a is k and b is p, so we can easily get rid of p. But look at this one, that here if you do something like this, you will get 2k. Now k is an integer, and say for this only 1 and 144, if you add them you will get 143, and in the left hand side there will be 2k. So if you divide 143 by 2, so k will not be an integer, so you will simply reject this case of plus 1 and plus 144, you will reject it. So hence now you will check all the values of k. It will take some time, and then replace k here, and then you will get the values of a. So you can do this. You can write all the factors, then add them, then find for what factors you are getting k as integer, and then replace it here, and then you will find the value of a. So I hope that this question is okay. So now I hope that you understood that question. That was a very lengthy question. The basic idea was to use that concept and some observation, and finally to eliminate the the possible cases. How that k is an integer, so whatever we are going to get in the RHS should be a multiple of 2, so that we get k as an integer, right? So now let's move on with the PYQ of PRMO, right? Very interesting question, you may have done or may not have done. So the question is, let a and b be integers. Okay, a and b be integers such that all the roots of the equation x square plus ax plus 20 multiplied by x square plus 17x plus b is equals to 0, and you are negative roots. Find a plus b minimum, like the minimum value of a plus b. So a and b are integers such that the roots of this equation are negative, then find a plus b, the minimum value of a plus b. Go on, pause the video and try to solve this. This is a PRMO PYQ of, I guess the year is 2017. So let's start. A very beautiful question, I would like to say. So first of all, it's the very first step is very clear, that x square plus ax plus 20 is equals to 0, and x square plus 17x plus b is equals to 0. Now again we have to make two very crucial observations. What observations? That alpha and beta are the roots, then, or generalize it, we will generalize it. Okay, say a, or not a, sorry, again, the k1 and k2, or m plus n. M plus n will be less than 0 for m and n less than 0, and mn will be greater than 0 for the same condition. This is the most crucial observation that you have to make, that if two quantities are negative, then their sum is always less than 0 and their product is always greater than 0. Very simple but very crucial for this question. So say alpha and beta are the roots of this equation. So alpha plus beta would be minus of a, and alpha beta is equals to 20. Again, break 20 into its factors. This would be 1 comma 20, then 4 comma 5, then 10 comma 2. Now another third crucial observation of this question. From here you can easily say that the minimum value of a will be 9, but some will say that -9, which is not true. How? Let me tell you. This side, if we look at the LHS, alpha plus beta, alpha and beta both are less than 0, so their sum must be less than 0. And if you are telling that a is -9, okay, so minus of a will be 9, which is greater than 0. So you see, this is not possible. Do you understand this? Do you understand this? Very very crucial point, very crucial point. Many of you may say that, sir, alpha and beta are negative, so so a will be -9, which is not true. Why? Because this side is negative, and if a is also negative, then -1 multiplied to any negative quantity will give a positive quantity. So this equality is not true. This equality will not be true. So a will be positive, and if a is positive, then the minimum value that a can acquire is 9. A is equals to 9, right? Now if now you some of you may have questions, like, if a plus b is asked to find the minimum value of a plus b, then why a and b are minimum? May come to your minds. Some of you may be there who may have this doubt. So to clear them, if we add two small quantities, then the result will also be small. I hope that you understand this. And if you are having this doubt, then it's a suggestion for you that don't prepare for a PRMO. Okay, now let's move on to the second equation, that is x square plus 17x plus b. So x square plus 17x plus b, again say alpha and beta would be say alpha and beta. Alpha plus beta is -17, and alpha beta is equals to b. Now from here, alpha and beta, the smallest value of alpha and alpha multiplied by beta is equals to b. Now we are asked to find the smallest value of alpha beta. The smallest value that comes to my mind is very simple, -1 and -16. If the value of alpha or beta is -1 and -16, then only we will get the minimum value of b. You can try it out with anything, so like -2 and how much, -2 and -15, that would be 30, and from here you are getting 16. See, so -1 and -16 is the minimum value of alpha beta. So from here we get b as b as 16, right? So a minimum is 9 and b minimum is 16. So a plus b, the minimum value of a plus b is 25. I hope that you understood this question as well. Now take some homework. The first homework is, say we have a polynomial. Okay, we studied polynomial, right? So we have a polynomial p of x, which is equals to, very simple questions I will give, extremely simple and extremely easy. X cube plus cx minus 5. This is a polynomial given p of -7 is 7. Find p of 7. This is your question. Okay, homework questions. And the second question is, say ax plus 4 is equals to 3x minus b has more than one solution. More than one solution, and solution for x. Now find value of 4a plus 3b 3b raised to the power 2021. Okay, these are your homework questions. I hope that you will do and you can submit this in our Google Classroom. Okay, now one last thing that I want to discuss, very shortly, that is the transformation of roots. Transformation of roots. We will discuss this briefly in another lecture, I suppose. Okay, so transformation of roots. Now, first of all, as the name suggests, we will transform roots. Okay, now first of all, we have to understand that we cannot use this every time in every situation. Now the question comes, then where can we use this? Very simple, we will use this whenever the roots are symmetric in nature. Now again the question is, what is symmetry? First of all, let us write where can we use this. Let's say TOR, short form, will be used only when symmetry is present in roots. Now what is symmetry? Symmetry, to be very telling you very simply, is that, say, a general equation ax square plus bx plus c has alpha and beta as the roots. So if alpha and beta, they are symmetric roots, then whatever will happen with alpha will also happen with beta. For example, if I add 2, then make a raise them to the power x, then with beta the same function, the same thing will happen. That is, beta, with beta we'll also add 2 and then again raise to power x. This is symmetry. We say, okay, one thing I remembered with symmetry. Okay, I have to teach you that also in today's lecture. Okay, so basically, if you look at the sine graph, you will find a line of symmetry, right? Line of symmetry, or basically this is it. If you raise x, whatever you will do with alpha, you will also have to do with beta. And if this condition is satisfied, then only we can use transformation of roots. Now, how to use transformation of roots? Let us understand this with an example. Say we have a question, very simple, very basic, extremely basic example I'm taking. X square plus 3x plus 2 has, say, alpha and beta. You can obviously find alpha and beta. That's not something to be proud of. Very simple. Now say you are asked to find say 2 alpha and 2 beta. You are asked to find an equation whose roots are 2 alpha and 2 beta. You can obviously do this with Vieta, no issues, but I am trying to make you understand transformation. So you see, can you tell me, are these roots symmetric? Yes, because here with alpha 2 is multiplied and here with beta 2 is also multiplied, so both the roots are symmetric. Now, how to approach this with transformation of roots? We will assume 2 alpha to be t, or t is just a variable. So I suppose that 2 alpha is equals to t. Now if you want to make a equation with 2 alpha and 2 beta as its root, so we have to make an equation, a quadratic equation in t. Are you able to understand this or not? This is the most basic concept of transformation of roots, that you replace the symmetric root with the variable and make an equation out of that variable. Now how to make an equation with that variable? Very simple. say 2 alpha, we suppose it is t, so here from here we get that alpha is equals to t by 2, and since alpha is a root of this equation, we can replace t by 2 in this equation. We can replace t by 2 in place of x, since alpha is a root of x square plus 3x plus 2, hence, and we suppose that 2 alpha is equals t, so alpha we got t by 2, then t by 2 will also satisfy this equation, so we can directly write that x square, sorry, let me replace x with t, so this would be t squared by 4 plus 3t by 2 plus 2 is equals to 0, because alpha is a root, and we got to know that alpha is equals to t by 2. Now our task was to make an equation in terms of t, and which we have. Now take the LCM and all this, and you will find the equation as t square plus 6t plus 4 is equals to 0. Now do you see, sorry, 8, t square plus 6t plus 8, right? So what was t? So 2 alpha. Now do you see that this is the equation whose roots are 2 alpha and 2 beta. This is the concept of transformation of roots. We will surely discuss it in brief with we will do more questions and all this, but first of all let me teach you the thing that I almost forgot. This is not very important for PRMO, but since we are learning quadratic equations and we are in the last step, so let's learn this. We all know this is the equation of the graph of a quadratic equation, and can you tell me the nature of the roots? We discussed it in this lecture only. This is imaginary roots with d less than 0. That's not the matter here. What we are willing to learn here is the maxima and minima of a quadratic equation. What is the maxima and minima? The maximum value of a quadratic equation and the minimum value of a quadratic equation. Okay, what is a, see, two graphs are possible, either this or either this. Not only this, now the graph can be also this or also this. We just took a general graph. Okay, now two graphs are possible with this curve, so here we will get the minimum value, because maximum, as you can see, is infinity, and from here we will get the maximum value as the minimum is also approaching infinity, right? So if A is what, now the vertex, what will be the coordinate? Now when we talk about the maximum value of the quadratic equation, what do we mean actually? We mean the abscissa. Do you know abscissa? X and y, so y is the ordinate and x is the abscissa, so we are basically referring to the abscissa of this graph at this point. So the abscissa for both the points is minus b upon 2a. Minus b upon 2a is the abscissa for both of the graphs. So we can say that if we don't know like maximum and minimum value, we will get through this expression, that is minus b upon 2a. Note it down, very important. The maximum and minimum value of a quadratic equation is this, minus b upon 2a. Now how to prove this? If you know integration or calculus, you can directly differentiate and the general equation, and you will find this same, or you can use the method of perfect square to find this. But I say, if you don't know calculus, I prefer you to prove this with the method of perfect square, and if you know calculus, then it's just a 2-second question for you. And I hope that you understand this is the maxima and minima value, both maxima and minima for a quadratic equation. And you can see the depending on the graph or the equation, you will get the values that whether minus b upon 2 is the maximum or minimum value. So I hope that you understood today's lecture. So thank you. Bye bye.